Okay, so here's the video, guys, and I'm going to go over types of problems that you could see on exam E. So I'm going to be doing these problems. So these bags are on the desks if you're in the room right now, and there's just like a bunch of like problems in here, and I'm going to do them in the video. Okay, so this is the top or the the lessons that are going to be on the exam. Okay, so I'll take these out. And my whole vision behind making these guys is that you could mix them up and then, reorganize them to know like what types of problems are in what category. Okay, but these are just in this order now. Okay, so quadratic inequalities. I took these two problems. I think they're both from our practice. And I'll just do one of them if that's okay. But these two problems are both like for you to do if you want in that bag. Which one should I do? I'll do this one. Okay. Alrighty. So solve the following inequality algebraically. So the very first move, guys, is to get 0 on the right side. So I'm going to subtract 14x from both sides and then also 5 from both sides. So we get negative 2x squared minus 14x plus 60 is greater than or equal to 0. Okay, so guys, the solutions that we're looking for, let me just take note of this now. Since we're looking for outcomes that make this quadratic greater than or equal to 0, or those are the outcomes we want, we're looking for positive or equal to 0. Okay. So now I have to factor this. So I could take out a negative 2 x squared x minus 30. Oh, God. I hope this works. 5 and 6. Oh, 3 and 10. Good. Alrighty, so two numbers that multiply to make negative 30 and add to make positive 7. Okay, so that would be, I'll do the factoring over here if this helps anyone. So x squared plus 10x minus 3x minus 30. Okay, I'm just like doing the factoring off to the side. So I'm taking out an x plus 10, taking out a negative 3, x plus 10. Okay, so now I'll go back into the problem, and this negative 2 comes down, x minus 3, x plus 10. Okay, so this was just like some side work for myself. Okay, so after you have factored, that's when you do the sign test. But you need to find the zeros first. So I'll find the zeros. So I'm setting each of these equal to 0 in my head. And then solving, I would add the 3 to both sides. So I'm getting x equals 3 and x equals negative 10. And then when you find the zeros, guys, you ask yourself, are these included? And the answer is yes, because we're looking for outcomes that are positive or 0. So at these values, the outcome is 0. And so we are including them. All right, so we're including those. So we'll need closed circles. Okay, so now I can go to this, to a number line. I'm putting these on the number line. Negative 10, 3. Okay, so closed circles above them. And I'm going to do testing points now. I'm looking for a different color. Okay, but I don't see one. Okay, so testing points. So I'll pick over here, I'll pick negative 11, I'll pick 0, and then I'll pick 4. Okay, now when I'm doing the sign test, I'm going to have all 3 of these. And this first one, since there's no x with it, it's always going to be negative. Okay, so I've got these 3 parentheses, and I have to do this sign test for all 3 intervals. So I've got 1, 2, 3. Actually, guys, let me do this. I like to separate like that. Okay. All right, so I'm plugging negative 11 in up here. This is always negative, so negative. Negative 11 goes in there, and I'm getting a negative. Negative 11 goes in there, and we're getting a negative. Guys, 3 negatives multiplied makes a negative, and we are looking for positive outcomes. Okay, so I'm getting nothing over here, so I could cross off that whole section. No solutions over there. All right, now I'll plug 0 in. This is always negative. I'm going to do it without the parentheses if that's okay. So negative, then I plug 0 in there, negative, 0 in there, positive. So a negative times a positive, that's a positive outcome, which is what I want. So I'll do like, just for now, a little check mark. And then I'll plug 4 in, negative, positive, positive. Negative, positive, positive. So that outcome is negative. So we would not be using that right there. Okay, so guys, the part of the number line, the part of the x-axis that we're using are those numbers there and everything in between. Okay, now, I think if you look at the actual D6 answers, they gave the answers as inequalities, but then on the back of this, I have the answer as an interval. You could do it either way, unless the directions say specifically one or the other. Okay, but let me express this interval. What is the left limit is negative 10. What is the right limit? 3. And then we are including them, so brackets. Okay, let's flip this over and see if I got it. I did. Okay. Alrighty. So now let's move on. I won't do the second problem. Let's move on to D8, absolute value inequalities. And guys, this was a big problem for people on the last exam, so I will do both of these. Both of these examples are from D8, okay? And I will do both of them. Okay. So this first one, solve the following inequality algebraically. So first I'm going to subtract 2, and then I will divide by 3. Okay, but I'll show those moves. All right, so first I'm subtracting the 2. So that's 18. And then I divide by 3. Okay, now guys, a lot of people, after this move, they're dropping the bars and doing plus or minus 6. That is only for an equation, okay? Now, if you really like that plus or minus move, that is a good move. We could do it for an inequality, but it is not within the inequality work. It's on a number line, okay? So off to the side, we're going to need a number line, and on that number line, we're going to put a plus, a positive, and negative 6, okay? All right, so this plus or minus 6 is still relevant. It's just relevant on the number line, not like within the problem. Okay, so 0 is in the middle, negative 6, positive 6. Okay. Now, because of the greater than or equal to, that means that we would be including these, because or equal to would actually be including those. Okay. But now let me go like this. Okay. Now guys, here is the thing. 3x minus 6. All right, we're wanting to drop the bars. That's the idea. So what does this thing tell us here? Absolute value is greater than or equal to 6. What this means in words is that, I'll do quotation marks because this is how you would say it, speaking. 3x plus 6 is more than okay, more than or equal to, but I'll just say more than, is more than 6 spaces from 0. Okay, so that's what you want to think. What does absolute value mean? This is what it means, distance from 0. So guys, if we are more than 6 spaces from 0, okay, so here's 0, 1, 2, 3, 4, 5, that's 6 spaces, right? 1, 2, 3, 4, 5, 6. That's 6 spaces left. But so that would be within this middle section. So any spot that is more than 6 spaces from 0 would be in these outer regions. Okay. So now I'm going to drop the bars. And guys, all of this work here is optional. It's just a visual. Okay, so the 2 places where 3x plus 6 could be are these outer regions. Okay, and now we set up 2 inequalities using what's on our number line. Okay, so the inequality over here is 3x plus 6 is less than or equal to negative 6. So on the number line, guys, the alligator is always going to eat what is to the right. Okay, so here, this one is to the left of negative 6, so the alligator would be eating that, the negative 6. Okay, so or, now for this section, we have 3x plus 6 is greater than or equal to 6. And then we just solve each of these. Okay, so 3x is less than or equal to negative 12. X is less than or equal to negative 4. 3x is greater than or equal to 0. X is greater than or equal to 0. Okay, so these are our 2 inequalities that we're getting. Now let me put them on a number line, and then I'll state my answer in interval notation. Okay, so x is greater than 0, less than or equal to negative 4. Okay, so the final answer, okay, so in this section, the left limit, there is none, so negative infinity. The right limit is negative 4, and we are including it, so bracket, union. This next section, the left limit is 0, and we are including it, and the right limit, there is none. It just keeps going, so infinity. All right, so now let me, or that's not it, it's this one. Okay, so now I will flip this over and see if I got it. And I did. Wonderful. Okay, let me do this next one. All right, so we've got negative absolute value of 9 minus 3x plus 6 is greater than 3. Okay, first move, subtract the 6. So we've got negative absolute value of that is greater than negative 3. Okay, then guys, this, before we go to the number line, we have to have this absolute value completely by itself. So I have to divide both sides by negative 1. So 9 minus 3x, when you divide by a negative, in an inequality, the sign flips because it changes the order on the number line. Okay, so now this is the plus or minus move, and it does not happen within the inequality. It happens off to the side. All right, so number line, plus or minus 3. Okay, I just wrote that in case it helps. But we go to the number line. 0, 3 spaces to the right and left. Since this is strictly less than, no or equal to, we're going to have these open circles. Okay. Now, guys, let me think this through in words. You don't have to write this, but this is the logic. All right, so I'm saying this to myself in words. 9 minus 3x is less than 3 spaces from 0. 9 minus 3x is less than 3 spaces from 0. Okay, well, here's 0. Okay, 1, 2, 3 to the right. makes me land there. 1, 2, 3 to the left makes me land there. Any further, and I will be in the outer regions. And I want to be less than 3 spaces from 0. So this 9 minus 3x, 9 minus 3x is right here in the middle, okay? It is greater than negative 3, but it is less than 3 in this middle section here. Okay, so we've got negative 3 is less than 9 minus 3x, which is less than 3. Okay, so now I have to solve for this. So I want x by itself in the middle. This is a compound inequality. So what would you do to the middle to get x by itself? First, we would subtract 9, and it has to be done to all 3 parts. So negative 12 is less than negative 3x is less than negative 6. Okay, then you would divide every part by negative 3, but be careful, we're dividing by a negative, so things are going to switch order on the number line. So over here I have a positive 4. This sign flips, x, that sign flips, 2. Okay, so let me draw this on the number line. This is optional, but it could help. So now I have a little number line here, 2, 4, open circles, everything in between. Okay, so that's the graph of that inequality. And as an interval, it's 2 to 4. Okay, so that was, whoops, this one here. And let me flip it over and see if I got it. And I did. Okay, so moving on, that was D8. Okay, so now D9 and D10. D9 and D10 are all about domain algebraically. Okay, so let me show you these problems. So we've got this one, this one, this one, this one, and this one. This is from D9 and D10. Okay, so those first 3 are from D9, and then, oops, I'm all over the place. And then those next 2 are from D10. These are all finding domain algebraically problems, and you have to know how to do all of them. So I will review real quick our functions that are parent functions that have restrictions. Okay. All right, so that's, you're going to want to know this. So parent functions with restricted domains. It means that the entire x-axis is not their domain. There is not a graph for every part of the x-axis. Okay, so there's this one, y equals the square root of x. Then there's this one, y equals 1 over x. Y equals natural log of x, but it would be true for any log, not just natural log, any log. The same restriction would work. And then also, this one we added only for a domain type of problem, 1 over the square root of x. So guys, if you know the way these graphs look, it could help you with the restriction. Okay, this graph, there is no asymptote. Whoop, it looks like that. This graph, there is an asymptote, 2 asymptotes actually, y equals 0 and x equals 0. Okay, and it looks like that. This one here, only 1 asymptote, x equals 0. Okay, and it looks like that. And then this one here, this is not one of our typical parent functions, but it could totally help when you are doing a domain problem. But this graph, it looks very similar to this one, except you can't have any negative x's under a square root. So we would still have these asymptotes, but the graph is only in the first quadrant. Okay, so you should know those pictures, and then this is what it helps you figure out. For this parent function, the x's are greater than or equal to 0. For this parent function, x could be anything except 0. So x is not equal to 0. Okay. For this parent function, you just look at the graph. X is greater than 0, not greater than or equal to, because of the asymptote. And then this one as well, same idea. All of these x's are greater than 0. So guys, these are the restrictions, and the one you set up depends on what the parent function is. Okay, so now let's move into these problems. Okay, so guys, I'm only gonna do 2 of them. All right, let me do this one. And then I'll also do, which one? I'll do this one. Okay, so I'm gonna do these 2. These are both from D10, actually. Okay, find the domain algebraically. So if you see something like this, you need to recognize that this is a product of square root of x plus 5 and 1 over 2x minus 10. Okay. Then you think of the parent functions. The parent function of this is radical x. It has restrictions, so will this. The parent function here is 1 over x. That has restrictions, so does that. So you set up the restriction. All right, so for square root of x, I know that what's under the radical is greater than or equal to 0. So I'm going to have x plus 5 greater than or equal to 0. 2 things are happening here. And what's the restriction on this type? The denominator cannot equal 0. So 2x minus 10 is not equal to 0. Okay. Alrighty, so this one here, I could just subtract the 5 and I've solved it. So no need to do anything more fancy. And then over here, I add the 10 and then divide by 2. Okay. All right, guys. So x is greater than or equal to negative 5. There's negative 5. Okay, so this graph looks like that. Ah, that's just an x. X is not equal to 5. This graph, a not equal graph, looks like this. I'll have 5 in the middle with empty space above and below it. There's nothing on the graph at that x value. But everything to the right and everything to the left does work. Okay. So guys, now I'm going to take these and I'm going to put them together on the same number line. Okay, and you don't have to show like all of this. Here's negative 5, close circle, everything to the right. Here's 5, open circle, everything to the right, everything to the left. Okay. Now, so we've got 3 sections to this number line. And means both. So we need to be seeing both of these number line graphs, and if we see both of them, it's good. That section is working for us. This first section, no good. We only have one graph, so there is no graph happening there. This section, good, and that section, good. All right. Now, this endpoint, we are not going to include, all right, there's an empty space above 5, okay? So there's a graph between negative 5, right, and then everything to the left of 5, but then empty at 5, but then immediately after we we have a graph. All right, so anyway, the domain is this. It is -5 to 5 union 5 to infinity. Okay, and let's just make sure I got it. That's the problem. That is the answer. All right. This one here. Find the domain algebraically. So this is natural log. I know the parent function has a restriction. So the x on the parent function is greater than or just greater than 0. But here instead of an x, we have 2x plus 1 is greater than 0. Subtract the 1, divide by 2. So 2x is greater than -1. Right? And then you could draw a number line, -1/2, open circle, x is greater, so the x's are to the right. So the domain is -1/2, not including to infinity. There it is. Wonderful. Okay, so we're still not out of D yet. Oh yes, now we are. Okay, so now finally E. Okay, we're gonna do E1, E2, E3, and E4. All right, so E1, log equations. So I'll just do one of these guys, but these are the two, in these little bags with problems, these are the two that I included that are E1 related. And I will do this one here. So solve for all values of x. All right. So guys, at a certain point, I see that I'm going to need to cancel the log base 2. And the way I'm going to do that is by opening up a base of 2 on each side of the equation. But I have to do some work first. Okay. So anyway, I'm looking at this. I see these two log base 2 terms, and they're being added, and if I could make them one single log term by multiplying. If that was subtraction, guys, you would be dividing. Okay. Now, guys, I am eventually going to have to distribute in here, so I'll do it now. 3x squared. Okay. All right, so let me just write this down. So this is log base 2 equals 5. Okay. Guys, there's more than one way to do this, but the way we've been practicing lately is knowing that you can cancel a log base 2 with a base of 2. So I open up this big base. I emphasize that it's big because the old equation is now, the sides of the old equation are now the exponents of this new one. And exponents are written small. So like this is now an exponent on that base. And you have to do it on both sides. So the 5 is now an exponent on that base. And you do this because putting a log base 2 on a base of 2 makes them cancel. So we have 3x squared minus 20x plus 25 equals 2 to the 5th is 32. And then I have to subtract 32 from both sides. I get 3x squared minus 20x minus 7 equals 0. All right, so now we're going to factor. So 3 times -7 is -21. So two numbers that multiply to make -21 but add to make -20. That would be -21x and 1x. All right, I'm factoring a 3x. Okay. 3x plus 1. Alrighty. So now I am setting each of these equal to 0 in my head and then solving. So for this one to equal 0, to get x, I'd have to subtract 1 and divide by 3. Guys, by all means, show those moves if it's not good just going right to it. And then over here, I would just add the 7 over. Now, guys, here's the problem. Logs have a restriction on their domain. And because this equation started with some log terms, these might be false solutions, okay? So the way that you could see this, you could just plug them in, and see what happens in the original equation, or we could check like this. So this would not be a full check because I'm not plugging them into the full equation, but with these log ones, you could just check the domain restriction. So x minus 5 has to be greater than 0, okay, for that log term. And then 3x minus 5 also has to be greater than 0. All right, I'll do that down here. So 3x minus 5 also has to be greater than 0. Okay, so for this to work, I need x's greater than 5. And for this to work, I would add over the 5 and divide by 3. So I would need x's greater than 5/3. Guys, look at these two solutions. Do both of these fit this criteria that they are greater than 5 and greater than 5/3? No, this one is extraneous. All right, so that is the solution. I hope I got it. Yes. Okay. So there's that. So that was E1. Now E2, square root equations. So let me find the E2. All right, so here's the two problems that I picked from E2. Right? Very similar. I'll do this one. This one is a little more involved. So solve for x. All right, guys. So you need to isolate one radical at a time. So this radical is actually already isolated, so I can move right to squaring both sides. But let me write this down first. Okay, so I can immediately square both sides. Squaring here. Okay, squaring over here, we got to do this. Okay, 3 minus x. All right, so radical x plus 7 times itself just gives x plus 7. Okay, and then times 2 would be 2. And then times 2. And then finally, plus 4. Alrighty, so let me combine like terms and stuff. So 3 minus x equals x. I'll add the 4 to the 7. 11. 4. Okay, so guys, just, take note of this. These were actually like terms. So we get 4 square root of x plus 7. Okay. Alrighty, guys. Now I'm going to move the sides, or I'm going to switch the sides real quick because I want to isolate that radical now. All right, so I am not like moving things around. I'm just switching the sides, and I'll put those after. So I'm just switching sides and moving terms a little. Here we go. Okay, so now we need to isolate the other radical. So I'm going to subtract x and 11 from both sides. Okay, so 4, subtracting the x and the 11. All right, so we're getting negative 8 minus 2x. Okay. Alrighty, now, guys, this radical is not completely isolated because of the 4 in front of it, the coefficient of 4. So you have some choices here. You could divide both sides by 4 right now. That might be a good idea. Okay. But if you do that, you're going to have a fraction, which might throw some people off. So if you notice that dividing would give you a fraction and you think that's going to like not work for you, then you can square both sides from right here. Okay. Guys, what's going to happen when you do that is, since this is all just one term, the 4 out front is going to get squared, like on its own, so that's 16. But then you're also squaring this square root, so what you're left with is just the x plus 7. So you have to be careful here if you're going to do it this way because the x plus 7 needs parentheses. Okay, and now this is equal to, so I'll write this twice. And I like to write the x first, so I'm just going to go like that. I'll distribute the 16 now, so it's 16x plus 70 plus 42. Is that 112? I just tried that in my head. 116 plus, or 16 times 7. It is 112. Okay. All right, now I'm going to distribute over there. So 4x squared plus 16x. Okay. So we got this 4x squared. So we're going to have to combine like terms and set equal to 0. Okay. And guys, if you see this right now, we could actually subtract these over now. So I'm subtracting 16x from both sides. So that would make like one of those cancel. And then we're also subtracting 112. So 64 minus 112 is negative 48. Okay, so I'm moving everything over there, but I'll keep my x's on the left. Okay. All right, guys, we're going to just keep going. So now I could take out a 4. And we're going to have to check the answer at the end because square roots have restrictions. So take out a 4. X squared. Okay, two numbers that multiply to make negative 12, but add to make positive 4. X plus 6, x minus 2. Okay, so I'm getting x equals negative 6 and x equals positive 2. Now, guys, we have to check this. Okay, so here is the check. And unlike the logs, we want to do a full check here, like plug it in, see if you get the same number on both sides of the equation. All right, plugging in negative 6, I'm getting the square root. 3 minus negative 6 is 3 plus 6. So that's the square root of 9. I put negative 6 in there, so I'm getting the square root of 1 plus 2. The square root of 9 is 3. Square root of 1 is 1. Okay, I'm getting it. All right. 3 equals 1 plus 2. Works. All right, check. Now I'm going to plug in the 2. So I'm plugging 2 into the first one, and I'm getting the square root of 1. I'm plugging 2 into the second one. Yeah, 2. And I'm getting 9. Square root of 9 plus 2. Guys, you can kind of already see this is not going to work. Square root of 1 is 1. Square root of 9 is 3. I'm getting 1 equals 5. Not true. Okay, none of that. So that one is extraneous, and that is our solution. Let's hope. Yes, right there. Okay, moving along. Next, we have E3, rational inequalities. Okay, so E3, these are the two that I grabbed from our practice. Okay, Let me think. I'll do both of them. All right, so this first one, when you're doing these rational inequalities, guys, the first move is to get the right side 0, and that is already done here. The second move is to get a single fraction on the left. That is already done. The third move is a sign test. Okay, so we are starting out with this problem on the sign test right away. And when you're doing a sign test, you have to know how to split up the number line. And you split up the number line with zeros and, in this case, also undefined values. If there are undefined values, you would use those as well. Okay, so for this type of case, zeros, undefined. Okay, so you're going to have a 0 when the top is 0. You'll have an undefined situation when the bottom is 0. Okay, so the top is 0 when x equals 0. The bottom is 0 when x equals 3. Okay, you will never include an undefined value. You will sometimes include a 0, but not in this case because this is strictly less than 0. Okay, so we are not including. We won't be including that. Okay, so now I do the number line. So we're still on the sign test. Number line, I'm putting 0 and 3. They both get open circles. And now we do a sign test. So I'll do -1, 1, and 4. So for this sign test, guys, I'm plugging into a fraction. So I want to see if I get like what over what, positive or negative. So I'll do this. Okay. If I plug -1 in the top, I get a negative. If I plug it in the bottom, I get a negative. Negative divided by negative is positive. Okay. But guys, what kind of outcomes are we looking for? Less than 0 means a negative outcome. Okay, so a positive outcome is not what we want for this problem. So since I'm getting positive there, I'll cross it off. Okay, now I'll plug in 1. I'm getting, if I plug it in the top, a positive. If I plug it in the bottom, a negative. Positive over negative is negative, which is the outcome I want. So I'll put a check. Now I plug in 4 and I get positive over positive. That's a positive. That's not the outcome I want. Okay, so this is my solution on the number line between all of the numbers between 0 and 3, but not including them. And flip to the back, and there it is. Okay, I'll do this other one. So this other one, these first 2 moves are not done for us. Okay, so we're going to have to do the first 2 moves and then the sign test. Okay, so first move is making the right side 0. So I will add this fraction to the other side. Less than or equal to 0. Okay, first move. Second move is to get common denominator, get a single fraction. So we need to get common denominators. Okay, so, or find, I'll say find LCD and then get the LCD. So this is where you're asking yourself, what is this fraction missing? And then you multiply top and bottom by what's missing, which is different than what we're going to do next for the next and last type of problem. So just be very careful. So here I am missing the x plus 8. Here I'm missing the x plus 7. Okay. So, and up here that'll be negative 3x minus 24. this will be 4x plus 28. Okay. So guys, what we've got here is negative 3x minus 24 plus 4x plus 28. Okay. All right, now I'll combine like terms on top. So we're just getting an x plus 4 on top. X plus 4. Okay, so guys, we have done these two things. Right side 0, single fraction. Now we're doing the sign test. Okay, so zeros, undefined. Okay, zeros are when the top is 0. So x equals negative 4. Undefined values are going to be where when the bottom is 0. So x equals negative 7, x equals negative 8. All right. Guys, in this case, since it's less than or equal to negative or equal to 0, this is being included. Included. Okay, so closed circle when I do the number line. Okay, so number line. Negative 8, negative 4. Closed circle. Definitely open. Okay, and now I'm going to do the sign test. And I'm going to have these 3 binomials. So we'll do like negative 9, negative 5, and 0. Okay. All right, guys, negative 9. So I'm plugging negative 9 in for all these x's, and I'm getting a negative, and a negative. Negative, negative, negative. Okay. Which is, guys, a negative over a positive, which is a negative. Okay, which we want. Okay, so that's actually what we want here. So check. All right, now I'll plug in negative 5 to all of these. Up here, negative, positive, positive. Oh, okay. Negative, positive, positive. Ah! I messed up. Oh, I'm sorry, guys. I can't make the video over. I can't do it. I have to just fix it. This negative 7 would be there. My bad. Okay. So, anyway, we actually have all these sections. My bad. Okay. So, over in this section, I'll pick negative 7.5. And then over here, I'll pick negative 5. Okay, so negative 5 is the one I just picked, and I ended up getting a negative outcome, which I did want when I plugged negative 5 in. Okay, negative 7.5. I'm plugging in for these x's. Negative, negative, positive. Okay, so I'm getting a negative over a negative times a positive. Negative on top. But then in the bottom, negative times positive is negative. So I'm getting a negative over a negative, which is positive, which I don't want. Okay. And then finally, plugging in 0, I'm getting all positives. Positive, positive, positive. Don't want. Okay. So my solutions are there and there. Okay, so the answer is from negative infinity to negative 8, union negative 7 to negative 4, and we include negative 4. Oh, yikes. Okay, I think I did get it. Okay, oops, forgot that negative 7. Sorry, guys. Okay, now, the next thing that we're doing is the last thing we learned, which you did do a lot in Algebra 2, and it is easy to confuse it with what we just did a little bit. Okay. Alrighty, guys. So the very last type, E4, rational equations. Okay, inequalities versus equations. So it's going to be different. And here I've grabbed some equations. These are all in these little bags. All right, so here's 3. Oh no! Gosh, it says inequality. These are all equations. Darn it. Just say solve. All right, we'll just say solve. Okay. And I'll do this one. This one right here. Okay. Now, guys, be careful because, well, all right, let me say this. So the last thing we did, we had to find an LCD and then we had to get the LCD. And what we're about to do for this other type is it's a similar start. We're going to find the LCD, but then instead of getting it so that they all have the same denominator, we're just going to clear the denominators. Clear denoms. All right, now, another thing though that you could do, guys, that I've overheard some of you doing it in class, is you could start off the same way that you would, like, if you're getting an LCD. So you would find the LCD, you would get the LCD, and then you would clear the denominators. So this method basically says that once you have all the denominators the same, you could just drop them, okay? Which is a little bit different than what I'm doing here. And over here, guys, I think this is what you did last year in talking to your teachers and just observing what you guys do. All right, but anyway, so here's our problem. 1 over... All right, and I'm going to go ahead and put the 1 over 1 right away. Okay. So guys, the very first move is to find the least common denominator. And in finding that, we could also look at our restrictions. So this one can be factored. I could take out an x. Okay. All right, guys. So, restriction, or let me say this. Or I'll just, all right. So the least common denominator is x times x minus 5. All right. And I will note right here that these denominators cannot be 0. Okay. Think of the parent functions. The denominator cannot be 0. So I have these restrictions. X cannot be 0. And then also x cannot be 5 because of that. So it could happen after I clear the denominators that I end up getting one of these as a false solution. So you just have to be careful. Okay, now for the clearing of the denominators. So I'm going to take each one of these fractions and I'm going to multiply by the least common denominator, every single fraction. And you're not multiplying the bottom by anything, it's just the top. And you're hoping, or no, when you do this, if you chose the correct LCD, the denominators should all cancel. So I'm multiplying every single one of these by x by that. Okay. Now let's see what clears or what cancels. So this x times x minus 5 is on the top, but this one is on the bottom, both of these. So the x's are canceling and the x minus 5s. Okay, now here, this x is canceling with that x. Over here, nothing is canceling. Okay, so now let me just write down what I've got now that the denominators have canceled. I've got 1 equals x plus 7, x minus 5, minus x minus 5. Okay, so now I'm going to distribute x squared Ooh. Okay, that's nice because the x squareds cancel, which means we're not going to have to factor. So that's great. All right, 1 is equal to, all right, those are canceling. So I have 7x right, minus 35. Okay. All right, so I have to subtract the 1. Well, let me just switch things around. 7x minus 35 equals 1. All right, so actually instead, I'll add the 35 and then divide by 7. Oh boy, that seems weird. Oh, I got it. Okay, that's it, guys. And we don't have to worry about checking because we already took note of what it can't be, of what x can't be. And this is not one of those things. All right, guys, I hope that was helpful. Bye-bye.